Welcome to Chapter 7, Section 7.1. We're going to discuss percentage and ratio strength. As we discussed in Chapter 6, the concentration of one substance dissolved in another substance may be expressed as either a percentage or a ratio strength, and how the concentration of the solute in the solvent is expressed as a percentage strength also depends on which is a solid and which is a liquid. So if we look at the whiteboard there, we can see that we have weight and weight, weight and volume, and volume and volume. The weight and weight is based on the number of grams, and that's going to be divided by 100 grams of the final product. Weight and volume is going to be based on the number of grams divided by 100 milliliters of the final product. So you're going to have a solid and a liquid, and volume is going to be based on the number of milliliters divided by 100 milliliters of the final product. Now, another thing to keep in mind when we are looking at some of the labels from Chapter 7, we have some abbreviations, D5W, that represents dextrose 5% in water. And one of the important differences between these labels that we're going to look at and the previous labels that we've seen in other chapters is that there's no milligrams per milliliters designated on the labels. You're just going to see those percentages. And that's because when the percentage of concentration is known, that percentage can be used to find the amount of active ingredient. And if you turn your book to page 180, we will look at an example. Example 7.1.5. Get rid of these formulas. These formulas are on page 178 for reference. And example 7.1.5, how many grams of dextrose are in 1 liter of dextrose, 5% in water. So again, note that dextrose D5W means dextrose 5% in water, or a concentration of 5 grams over 100 milliliters. So that's important to remember. And of course we know that 1 liter equals 1,000 milliliter. So what we're looking for are how many grams of dextrose, and that's going to be our variable. So when we set up our proportion, we have our variable that we're trying to solve for over 1,000 milliliters. And we have our percentage, 5 grams over 100 milliliters, and that is following the weight in volume proportion. So now we can solve for x. Those cancel out. 5,000 divided by 100, and x equals 50 grams. Now, if we look at the next example, this is going to talk about percent strength. The percent strength of solid solute and a solution is always calculated in the same manner and is expressed in grams per milliliter. So the formula we're going to follow are grams of solute divided by milliliters of solution, and we're going to take that times 100. So for example 7.1.6, if there are 30 grams of dextrose in 500 milliliters of solution, what's the percentage of strength? So we're going to take 30 divided by 500 milliliters times 100. So 30 divided by 500 gives us 0.06 times 100, and that is going to give us 6%, and it's going to be weight and volume because you have solid and liquid. And that's just written as W/V. Okay, so let's go ahead and turn to our practice problems. Problem set 7.1 on page 182. We're going to work out a couple of these, both kinds. Let's look at number 4. If a patient drinks 8 fluid ounces of milk, 2% milk, how many grams of fat were consumed? So we're looking to find grams, and we know 2% is 2 grams over 100 milliliters, because that is we're talking about milk, so this is a liquid. 8 fluid ounces, we know that there are 30 milliliters in an ounce, so we have 240 milliliters. Now we want to solve for grams, so that's going to be our variable. The amount that we're talking about is 240 milliliters, and it's going to be grams over milliliters. Make sure our units of measure line up, and we can go ahead and solve for x. These cancel. Milliliters cancel. 240 times 2 is 480 divided by 100, and x is going to equal 4.8 grams of fat. Okay, let's look at number 5. An injection of 1.3 milliliters of lidocaine, 2%, was given. How many milligrams of lidocaine is this? So we want to solve for milligrams for x, and our amount is 1.3 mils, and we know 2% written as a fraction is going to be 2 over 100, and this is going to be grams and milliliters. Now if you see the problem, we have grams, but then we have milligrams over here. Since we're solving for x, we're going to initially solve it as grams, because we have to keep this that way, and then after we get our proportion solved, we will convert it into milligrams. So we can go ahead and solve for x. Milliliters are going to cancel. 1.3 times 2 divided by 100 is going to give us 0.026 grams. Now remember, we need to convert it to milligrams, so we're going to move the decimal. 1, 2, and 3. 26 milligrams will be our final answer. Okay, let's look at number 6. A dose calls for 2 capsules of 300 milligram rifamycin to be given in 1 fluid ounce of cherry syrup. What is the percentage of strength? Okay, so first it's 2 capsules at 300 milligrams, so we're going to just multiply that. It's going to give us 600 milligrams. 1 fluid ounce, we want to convert that into milliliters. We know that's going to be 30 ml. Set up our proportion. We're going to convert this. Remember, we're going to have grams over milliliters. So we're going to need to convert this to grams. 1, 2, and 3. So we're going to be 0.6 grams over 30 ml times 100. Because remember, we're not setting up our proportion like we normally did. We're looking at that second formula for percentage of strength. So if we take 0.6 divided by 30 times 100 rather, it is going to come out to 2%, and that's going to be represented as weight and volume, because we have a solid and a liquid, and that's W/V. Okay, let's look at a couple more percentages of strength, remembering that that's the formula we're going to use. And if you want to refer back to that formula, it's listed on page 180, and it's also listed at the bottom of page 178. So let's look at number 7. It's going to be another percentage of strength problem. Calculate the percentage of strength of drug in the following drug formulations. Clindamycin, 75 milligrams over 5 ml. Okay, so it's 75 milligrams and it's 5 ml. So remember though, it's represented as grams and milliliters. So we have our milliliters, but we're going to have to convert this to grams. Move the decimal 3 to the left, so it's going to be 0.075 grams. 0.075 grams divided by 5 times 100 is going to give us 1.5%. And again, solid and liquid, so weight and volume. Okay, let's